Yeah, we're live. We wanted to discuss some landing strategies.
It's just one topic because I was looking back at several missions and including most recently we talked about the lander that was including YaOki, but also I think one or two more other rovers. And again, because of a landing problem, none of the rovers could do anything. Okay, so I remember a mission a bit earlier a few months ago where the rover was also damaged. So end of story. Okay. But here, the YaOki team tells me that the rover was fully functional.
So
But
you know the guys who
sorry,
built it. You know the guys who built it.
yeah,
Okay.
yes. I don't know the guy who built it directly. Okay, I know people in his team. Okay,
Okay.
the guy who built it is someone I wanted to meet a few years ago, and I missed a chance. And after that, I had to move to other topics anyway. Um, um, but I know people on the team. Okay. And so the thing is that YaOki, at least YaOki, I don't know about the other rovers, okay? I don't remember even who the makers are. But there was a hopping robot also, okay?
Mhm.
At least
Ah, yeah.
YaOki was fully functional, okay? And so the thing is that, but the landing, they landed in the shade, okay? So they were, it was 200 meters from the spot that they targeted where they would be charging all batteries, basically, okay? And I don't remember. I think YaOki then just had battery for a few hours, so they just took a few pictures, sent them, okay, and that's it, okay. But otherwise, it was functional. Um, I remember a comment about at least one over that was blocked by the one of the legs of the lander that tilted, okay. And so, and also we talked about something else last time. Is that lenders now it's more into automation, right? Into automated lending, and that may be one of the reasons why several of the lenders recently fail because we don't have so much feedback about past experience of automated lending. Usually, it's remote control or something like that, right? So with a human in the loop. Okay. And so all that for me adds up because I'm not sure whether we can consider lender as a robot. Okay, it's a satellite. Okay, I'm not sure whether we can consider it a robot, but if we're talking about automated landing, okay, so it's a very specific kind of robotic task, okay, but still, for me, it qualifies as a robot and pretty much in line with many of the interest we have seen the creation of this group, basically. However, we have focused on the rover itself, okay, or the rovers, okay, if we have a team of rovers and so on, okay. For me, I'm just proposing the topic as perhaps interesting to at least discuss because there may be innovation to do there because there are so many teams working on rovers in the first place, but not so many teams apparently working on landers. That was
Because it's expensive, right?
yes, yes.
Which was the Mars rover that landed with these balloon uh, bumpers? They just threw it out, and which was it Spirit and Opportunity or the previous one?
I don't remember. There are parachutes, right, in several
Yeah,
missions.
parachutes, and then at a certain height there were some balloons.
Hmm. It's interesting because the balloon links to previous discussions we had on wheels. Okay, um, on inflatable, possibly inflatable wheels, right? But you see, the balloons and so on, so they may cover a range of issues. But for example, the lander, which was bless you, um, the lander for intuition machines. Okay, the lander for YaOki. Okay, so if I'm not mistaken, it weighs several hundred kilos. Huh? Okay, so it's not a small. It's in the small range, okay, but there are much bigger ones, but it's still not light, okay. And the thing that it landed, but it also tilted after that, okay. I'm not sure the balloons would maybe they would help for the landing itself, but perhaps not about the tilting. Okay,
Yeah, somebody has asked the same question. How did they land upright? I'll share the screen
right. Yes, yes.
after bouncing. Uh,
Wasn't it supposed to bounce?
no, but it doesn't need to land upright, right?
Yeah, it's a
Something has to be.
tetrahedron. It was shaped like a tetrahedron, so whichever side it landed, it opened like a flap and sort of like self corrected. I think that was the idea.
You cannot basically watch YouTube without logging in.
Hmm.
Okay, so as a tetrahedron, it would okay at that stage get back to its
No, but
fixed.
it something was like still they had to roll right once.
Yeah, if it's on the correct base, then all three other sides open like petals. If it's not on the correct base, then it acts like a lever and pushes it on the correct base. Think about the geometry of it. If it's on all
Okay,
the
okay.
sides, only one of the forces will act. But if it's on the right base, all three will act, uh, or not act rather.
Okay. So they just inflate or do something on one side and then it rolls. Probably.
I think all three. I think all three, except for the base, have actuated unfolding hinges. So
Okay,
if it's
okay.
on the wrong side, only one hinge will be relevant. But if it's on the right side, all three hinges will be pushing down. But this only worked for Pathfinder because it's a fairly small rover or whatever this is, Spirit Opportunity.
Right, but
It's
it may also affect the balloons because it depends on the weight, right? If the maybe for perseverance or the other one, curiosity, which are much bigger than Pathfinder and so on. Maybe the balloon approach doesn't work, but perhaps that's why they went for a parachute, basically, right?
parachute till the lower descent. The lower descent was retro rockets. If you see the video, Curiosity and Perseverance, they had like a hovering retro rocket landing thing
Mm.
that finally lowered it with a system of pulleys. But honestly, I think beyond a certain weight, that's the only solution. And on the moon, you can't even use parachutes.
Yeah.
Yeah, the moon is really hard, and I think the hardest planet on in the solar system is Mercury, because Mercury, the orbits are weird, and you come in at a very high velocity.
It's also a big rock, right?
I don't know that that makes much a difference. I mean, the moon is a rock, Mars is a rock, but Mercury, I think the main problem is the orbital mechanics are very bad.
Mm.
There was the Beppo something mission that
Bepi Colombo, I think.
yeah, Beppo Colombo. I think it dropped not a lander, but some sort of like one of those penetrating, it just falls down kind of things. Yeah, I think landing a rover on Mercury would be quite hard.
But wasn't the Japanese rover supposed to be like a ball that you can throw into a cave and it can bounce around? So it's kind of resistant to any of these problems.
So it didn't go off the lander or what happened there? It should have been able to. at least move, right? What happened there? I didn't exactly understand what was the problem.
You mean to the?
Yeah, okay, yeah.
My understanding is so since they landed in the shade,
Ah,
so the question immediately was about power management, what to make the best use of their power. Okay? So apparently they had power to move and it was whole functional. But after some discussion, they decided just to take pictures, not to use power at all to move. So take pictures and send them back to Earth.
So it didn't have power to move 250 meters.
Apparently not. No, I didn't ask that exact question, but apparently not.
Yeah,
So
because it landed some 250 meters from the intended side of the lunar south pole,
yes. Hmm.
where it was unable to recharge its solar power and oriented away from the sun.
So you mean to cover 250 meter to get to charge up then?
Yeah,
Well, that's a risk management question, right? Okay, I think they chose to get something back instead of trying uh, something more risky, apparently. Okay, but yes, that's a good point. But if I'm not mistaken, the original mission of the rover, okay, was to move around the lander. Okay, so it's like so the first time they send anything, okay, and so they set the bar perhaps at that level to move around the lander, something like that.
so what would you do in order to avoid this problem next time?
But yeah, it seems the problem is once more because it's not the only time. Okay, we've seen that several times over the past 3 years, I think.
yeah.
It's not the lander. Okay, so either the lander just crashes. Okay, so then everything disappears. Okay, so to avoid crashes. Okay, but after there will be the problem of tilting. Okay, and there is also the landing site. So it's about precision of landing, right? So these are
Yeah.
the bunch of problems that and of course we're talking about automation here. Okay, so these are the problems to address. Okay. So what to do against them? Honestly, I haven't really thought about them in detail. It's just that it looks like an interesting set of problems to deal with. Uh, Maybe involving some AI. Okay, so AI broad sense, huh? Not Gen AI, perhaps.
That's a good breakdown. I think the first problem is basically facing really hard physical limits. Like you're coming in at a certain velocity from orbit, and it's like basic physics. You have to shed a certain amount of momentum before you can like come to a velocity where you won't like burst into pieces on landing, right? So
Hmm.
part one problem is like very hard constrained physics. Part two, I think, is kind of interesting and more solvable. Like, assuming you hit at a velocity that does not like smash you into pieces, so you're like at a wrong attitude. What are various schemes for getting into the correct attitude? And the third problem of like something like energy. What is it? Was that your third problem? Like not having enough energy or something? First was
Yes.
reducing velocity. Second was correcting attitude. Third one is like getting enough energy, right?
Yeah.
Yeah, so basically it was just
Right.
250 meters away from the intended landing site, and then it landed in shade. So if a lander has landed and it can orient itself in any direction, and if there is enough energy, it should be able to move 250 meters and then charge.
I mean, motion is like a couple of orders magnitude more expensive than photography. So I would say the order of magnitude analysis here is motion is the most expensive. One order of magnitude less is probably communication. Like long distance RF is probably very high power, but photography is the cheapest of the lot. So I would say for problem three, an interesting strategy might be something like if you're a I don't know 100 kilogram rover and you don't have enough energy to move 100 kilograms 250 meters, maybe something you can do is like almost with like a spring loaded catapult launch a solar panel to 50 meters, right? Like almost a blanket type thing rolled up, shoot it connected with a cable so that the solar panel goes in the sun. You can charge and then bootstrap enough energy to run your motors. Something like that could work. Like, why do you have to move the full mass
Right,
that distance, right?
right.
And yeah, I don't know, like you could have some sort of nuclear reactor. Then you don't need solar energy, right? Like you could just land the charging station, uh, which is powered by nuclear energy, and then basically the other things can roam around and then get the charge from there when they are not having charge. So that is like one strategy you could. But then how do you land the nuclear reactor there?
Oh, so
No,
I'll
I think that
I'll tell you.
sorry, we covered a long time ago that question at nuclear, and there are concrete projects, with micro reactors, like
No,
kilowatt reactors, very very small reactors, and so that may be actually a serious option, right? Sorry, Mayor.
no, I was just gonna say they just came out with a new carbon 14 based solid state. Let's call it a battery with beta radiation from the carbon 14 hits a semiconductor and generates a little bit of power. So it's not so weight efficient, but you can store up the power and then walk. And then you can wait another year, storing up the power, and then take another step.
Another possibility is if you have lots of little rovers, you have them land scattered over a whole area, and the ones that happen to land in well lit areas, they charge and then go help their friends out. So
Ah, okay, so your solution is to print out, yeah, there's something newer than the diamond battery. So your solution is to drop 4 rovers, hope one of them falls where it should, but it can't do the mission by itself. It has to go find its friends and help them.
yeah, so it'll go charge and then recharge the others. Then you now have 2 rovers, and both of them go charge themselves and charge the remaining 2, and all 4 are back online.
Right.
So something like that could work. But the
Assuming they are not riding the same lander, right?
Hmm?
Assuming they are not riding the same lander.
That's a good question.
No, you
When
don't
is
have to
this?
land, right? You don't have to actually land any. So you could just have some sort of orbital uh, lander or like satellite, and then it could just throw a few rovers here and there.
On that one, I think the US wanted to do something like a gateway, a lunar gateway. Is it something progressing?
I think it's being built, right?
I don't understand your proposal, Anuraj. The low lunar orbit or low Martian orbit, you can't just throw from there. You need a proper lander. Like the kinetic
No,
energy.
on the moon. On the moon, you can, because that's how the Apollo missions were done, right?
No, Apollo was piloted landings. The lunar modules had pilots
Just
who
piloted, yes.
controlled it with,
They had little joysticks.
yeah, they had full retro rockets and stuff. You can't throw anything on the moon. It's kinetic energy will explode anything you throw. So yes, you need some braking mechanism. The Chandrayaan Indian mission, I think it had 5 retro rockets, and the first one failed because one of them had excess power, so it became unbalanced. Then the next mission, they kind of fixed that and it landed. But yeah, I don't think you can land on the moon without retro rockets.
Right. It's very thin. Very thin. I don't even. I don't. Do we
No
qualify that an
atmosphere,
atmosphere?
effectively no atmosphere, so you'll just get full acceleration due to gravity from orbit.
No,
So
no atmosphere, but there is gravity, which is like a third of or a sixth of the Earth, right?
yeah, that's at the
Yeah.
surface.
Yeah. Yeah.
From orbit, you'd have to do the calculation. But remember, what you're doing is from low lunar orbit, you'd give it basically a deorbitaling burn, and that'll kick it into like an intersection trajectory, and it's going to accelerate the entire path. So if the glide path is something like, I think the missions I saw were like 30, 40 degrees. So it's coming in at a 30, 40-degree angle. It's accelerating the entire way to the surface at that, 1/6 maybe, but it's still a lot. So that by the time it arrives at the surface, it'll be like hundreds of meters per second. It'll be like a bullet, basically.
Right.
Yeah.
So, is it interesting to have an orbital, though, that could remotely charge?
So
A rover in the shade.
schemes like that,
Just
like
enough energy to get to the sun, basically.
you can do that. So there have been schemes for power generation on Earth, where you have like a very big in orbital like solar panel, and then you convert it into a very focused maser beam. So maser
Mhm.
is microwave laser, and you beam it at a ground station that receives it, and that's an energy transmission. So it's feasible. It depends how tightly you can target and stuff. So basically, yeah, you charge up the rover by shooting radiation at it in laser form.
Right. And that's another also advantage on bodies that have no atmosphere, because the laser accuracy may be easier to tune.
Yeah.
Perhaps. I don't know, but
Long term, though, I think the goal would just be a one-time task of building up infrastructure on the surface itself. So you
right.
would, yeah, put down a bunch of landers, put some charging facilities. So anything that comes down, the robots that are already there will go turn it the right way up and charge it and get it back in motion. So
Or they can put out a big balloon. So I guess maybe the question should be, what structure can you build out of regolith, which helps lunar probes land softly? You add some foam and get some sort of foam pillow.
Mhm.
I wonder if a trampoline type thing would work, like a very big net made out of like some tough material like Kevlar. You could just catch it. Like, I mean, there are systems kind of like that. Like, yeah, aircraft carrier landings, they have the arresting cable. That's basically a mechanical stop. It hooks the airplane and slows it to a stop. That's like a very simple net type thing. And there are drones that are caught by nets.
But that's exactly why I suggested making something out of regolith, because the bringing a Kevlar net, like an aircraft carrier net, is very expensive.
If you had a big crater, you kind of have the structural part of a net already done. You
Yeah,
could
but
like,
the net itself, somebody has to bring, a ton of Kevlar, and it has to land.
well, it's still better than bringing a ton of steel to build towers and construction and stuff. So yeah, yeah. I don't think you can build entirely out of lunar materials, but you can like maybe do
Metal.
80%. It's like countries doing domestic import substitution. It's like what's in the domestic economy of the moon, so that Trump can't charge tariffs against it.
Well, not on the moon. Well, actually, who knows?
He might do that. I mean, oh well.
Well, imagine you build a $1 billion lunar project and you get to the moon, and then you get slammed with, well, first, the landing works because they want to put you in confinement, but then you have to pay, a 20% tariff.
But yeah, going back to the three problems in Eric's breakdown, slowing it down, yeah, other than things like nets and balloons and stuff like that, there's no obvious way other than retro rockets. It's like basic gravity well problem. The third problem, I think there's some creative solutions possible. The attitude correction, yeah, that one, I don't know. It feels like the tetrahedron strategy could be generalized. Like, why didn't these rovers that landed like on their side or something have like a very simple actuator flap type thing that might have helped them get back on their feet? Are there? I think legged robots can actually like just stumble themselves so long as the motors of the legs don't break. Like the thing we saw a couple of weeks ago in one of our link openings, the it was clambering all over rocks, the very big spoked wheel type of thing. Do you guys remember that one? There were a couple of
Ah,
really
yes.
Ah,
weird.
yeah, yeah.
The Swiss robot. It was some. I think it was from ETH or EPFL in Switzerland.
There were two. One looked like a big two wheeler with like spokey wheels, and the other was a very reconfigurable thing that kind of like made itself all sorts of shapes, like a ball and other things, and it could float. So
Mhm.
yeah, but those, yeah, I think there's a trade-off here between how much impact velocity it can withstand and how much reconfiguration you can do, because any reconfiguration mechanism, it's going to have hinges and movable joints, legs, things like that, and these are going to be fragile. If it hits, it's going to break. Whereas something very compact like a rolled up ball, it's more likely to survive a collision. So I think there's a trade-off here between sort of like mechanical dexterity once it's on the ground versus survivability of crash at a higher velocity.
Right.
It was this one.
Oh yeah, yeah, this is a pretty good one.
The goat. Okay,
Yeah,
so the
yeah,
strange name. Yes.
the long leg one.
Yeah, this is basically a net that's falling from the sky. It's like a fishing net from the sky. But yeah, no atmosphere. Even this would potentially break into pieces, I think.
No, you could have some sort of small explosive, right? That reduces the speed. You don't need
Mhm.
a full rocket engine type of mechanism. You could just explode something to slow it down.
You'd still need a certain amount of like attitude control to point the direction of the explosion correctly a little bit.
Okay.
Do you guys remember the old Orion project, the nuclear propelled
Yeah,
rocket? So
Mhm.
that
yeah.
was basically a series of explosions. So the idea of that was there's actually a video of that. They never made it nuclear, but they made a conventional explosive version of it. Let me find the video. Hold on. Yeah, Anuraj, can you play that
Yeah.
video I just posted? Yeah, this is kind of like your idea, somewhat loosely directed explosions, but this is still it's a directed charge. Yeah, see this?
Yeah.
Yeah.
Yeah, so this was done with conventional explosives, but the idea was you would do this with like a really large rocket and nuclear explosion, and there would be an ablation plate. So I saw it described as like frog kicking your way to space, which is the right description. It looks like a frog kick swimming motion, periodic explosions.
Scary.
But this is very robust. Like you don't have to care about the center of gravity much. Things can be like randomly placed in the payload fairing because the explosions are so powerful. If you point it roughly in the right direction, it'll go up.
Well, the question is, are the nuclear explosions going to be slowed down, by some sort of damping?
Yeah. They had like very thick ablation plates at the bottom, and that was a big part of the design. How do you design the ablation plate to actually withstand the nuclear
Yeah.
explosion and stuff? But you don't have to do
What
this.
is
You can use
what is an ablation plate?
something that can be worn away. So like a material that's sacrificed for the
Okay.
explosion. Yeah, yeah, that actually ended up being a big part of the design, if I remember correctly. This was like in the 1960s. But yeah, so the explosion idea kind of works if you have some amount of attitude control. But to get some amount of attitude control, you need like really strong like control gyros or
Mhm.
retro rockets. So yeah, the whole descent phase is just super constrained, I think.
So explosions could be used for the descent as well, right?
Yeah. So here's the worst case I can think of. You eject it from low orbit into a descent trajectory. There's no attitude control at all, but there is attitude detection. So it's rolling and spinning in all sorts of directions, but it can detect when it's pointing in the right direction, and it opportunistically does explosions, right? So when it's the downward facing camera is pointed at the surface, boom, it sets off a little explosion and tries to slow down, something like that. So you can probably do a little bit of descent control even if you don't really have attitude control. Yeah. But yeah, it seems very inefficient. Yeah, you're not going to get very high efficiency unless you have attitude control.
Is it light?
No,
Explosives
but
are
it's also about being cheap, right? Because the more efficient you try to be, then it becomes more expensive.
right. But there is
Well,
also the question of weight, huh?
yeah, wait, that's what I was going to say. In space, efficient means lightweight. So if your thing is inefficient, it's probably going to be heavier. So it's going to be more expensive to get up there in the first place. I think for descent phase, you can't do it without retro rockets, really.
Mm.
And that's not such a bad thing. I think fair the they're fairly lightweight because you're trying to slow down a descent. You're not trying to reach escape velocity, and uh, climbing into a gravity well is cheaper than climbing out of a gravity well. So retro rockets are not that bad. I think it's
Yeah, I don't agree with what you just called cheaper. Um, Leaving a gravity well, you're kind of flexible with the direction in which you apply your waste, your energy. Going
Hmm.
into a gravity well, if you want to make it part way, it's easy. If you want to make it all the way to the bottom, you need very, very good control. So I don't think it's easier.
no. There's two components, right? One is just shedding momentum altogether. So like there's a
Right.
difference between hitting the ground at 10 meters per second versus 100 versus 1000, right? So if your thing can handle falling at 10 meters per second, even very rough velocity reduction to 10 meters per second will do the trick. So there's
But you have to aim it in the right direction, or instead of reducing your velocity, you could even increase it.
yeah, that's why I'm saying you need either attitude control or you need opportunistic. If you're pointed in the right direction, do some braking.
Have you
Yeah.
heard about this Tom Muller's new company? Basically, they're trying to make some rockets or rocket engines for last mile delivery.
Hmm.
What does that mean, rocket engines for last mile delivery? Do you have 1,000 miles in the middle?
Oh, well, I think you need some attitude. What when the problem Venkat was describing, you need a small attitude control when the satellites are delivered. So I think what his
Oh,
target
oh, the
market
last
is.
mile in the sky. Okay, okay.
Yes,
I
yeah.
thought you meant
So
underground.
no, no. But it could be anywhere, right? I think their overall goal is to be on Mars too. But right now they are targeting satellites with small rocket engines. Basically allows attitude control. I mean, when the satellites have been ejected from the rockets.
So the technology is what much smaller,
At
much
least it
more.
at least it seems so. I
Hmm.
haven't checked them in a while.
That's one thing that for the landing. Okay, so let's assume that we need rockets. Okay, to slow down. I don't know. I don't know well what were the old technologies, but I remember pictures of for Apollo, where they look pretty big, basically. But either maybe they are big, but maybe they are easy or relatively easy for pilots to control. While if there are many small ones and there is a computer to guide them, okay, and so then with the proper automation, are there advantages in doing that? Like having many small engines, that could be benefit for redundancy. No, I don't remember, but some of the SpaceX rockets, some of them, they have redundant engines, right? If they lose 2, 3, 4, it's still just fine, right? Something like that.
Yeah, all of SpaceX's rockets, they have lots of small engines instead of a few big ones. So I think
Mm.
the Raptor engines are used like 36 of them or something weird like that. Whereas more typical rockets have like 3 or 4 large engines.
Right.
I was actually about to look at the Blue Origin rocket. So Blue Origin's rocket has a different combustion technology, so I think it's larger. Oh, there's a
Mhm.
very good episode on one of the hardware engineering newsletters I read about how hard it is to build rocket engines. I'll post that.
But these are quite small from impulse space, the rocket engines. I didn't know you could make rocket engines so small.
What do you mean? You make small rockets. You have small rocket engines.
No, but you need, I don't know, certain amount of strength of the materials, and I don't know how to contain the explosion, right? It's
Ah, you
basically a
mean liquid?
controlled explosion.
Not
You mean
really.
liquid
Regular,
fuel?
yeah. Only when you get up to like liquid fuel, pressurized oxygen and hydrogen kind of levels, do you need like really strong materials. Solid fuel boosters can be regular strength, like aluminum, steel, all that material will do. But yeah, liquid fuels and pressurized fuels, it starts to get really tough. But all these small things tend to be solid as far as I know. But I think explosions are an interesting, or generalizing from explosions. I think any one-time use mechanism is an interesting actuator to consider for one-time mission profiles like you're talking about. Like I was always fascinated by pyrotechnic fasteners. Have you guys heard of this? This is how like things like solar panels are
Yeah.
released. So there are explosive bolts. So it's one time you set it off, it explodes and it does one mechanical action. So I think a lot of these things like landing, attitude correction, it's like uh, I posted a link in the chat, pyrotechnic fastener. Yeah. So they use this to anytime you just need to separate two bodies for one time in like a with an
Yeah.
explosion, you can use techniques like
Explosive bolts. Yeah.
yeah,
Especially when you have two stages
yep.
and you need to separate the old stage.
Here's one way we could use it. Like take this rover that got stuck in the shade and needed to go 250 meters. Don't make the motors do this. This is a one-time job, so you could have like an explosive pulse that just like boom explodes, and then almost like a football, it tosses the rover 250 meters. So you can think of like one-time solutions like that. So it's actually a twist on Anuraj's idea. Instead of using explosions to slow down on the way down, once you've landed, you use an explosion to throw yourself in the right direction. You can also use springs, I think. Well, if the temperature is if springs work at that temperature, you can use springs, like a preloaded compressed spring.
I or it could be just compressed air, right?
Yeah.
No, that would not be efficient. An explosion is much more efficient than just
Then
compressed
compressed
air.
air. Yes.
Compressed air can't lift much load. Pneumatics are relatively limited.
Except if you look at that, it's much easier to control. I put the link of the pneumatic robot that it slowly releases the compressed air and it walks with it. So again, you have the issue of how much energy and how much control. If it's a one-time device, you don't want to waste mass on a complex control system. And the more energy you have, the better control you need.
So here's another direction of thought. Anytime you have an atmosphere, you can use the atmosphere not just for braking, but for passive control, right?
Yeah.
So you can have ailerons and things like that, and you can do things like, for example, you have like a spinning top type lander, and it'll basically correct itself to the right attitude using aerodynamic forces. But you can't do this on something like the moon where there is no aerodynamics for like control or braking, but you can do something else. You can use like other types of friction losses. And here I'm thinking of an early satellite, Explorer 1, I think. Um, it was spinning along its long axis, and it got unstable and started spinning on its flat axis. And the reason was it had a lot of like flexible antenna type things. And when those things began vibrating, they dissipated energy through just internal friction. So
Mm.
that energy drain kicked it from like an unstable rotation mode to a stable one. Now, that was a failure in Explorer 1, but I wonder if you can use something like that to uh, stabilize like a zero atmosphere lander. Like basically, you need an energy dissipation. So energy dissipation is one problem, and velocity and momentum shedding is kind of like a coupled problem. But you can kind of lose energy for attitude correction without the need for an atmosphere, I think. Let me see if I can find that Explorer 1.
Is it this one?
I think it is an American satellite, not Russian. I might have gotten the name wrong. No, it was Explorer 1, United States, 1958. It was this one. But this was the satellite itself, not the rocket. So this, once the satellite was launched in space, it was spinning on the long axis, and then they lost control and it went into a flat spin.
This is mostly about launchers.
Yeah. And yeah, I'll see if I can find a better link for this. Yeah. Oh, scroll up. That picture actually kind of explains it. Yeah, that one. Those
Mm.
things sticking out are the flexible things that I think started vibrating and shedding, dissipating energy through internal friction, and that was enough of a
Well,
drain to despin this. Yeah, I guess
well,
this is satellite. The rocket itself was a satellite. But yeah, landing is a difficult problem. Oh, another extreme solution, if you have enough infrastructure, you could have like a downward space elevator with a tethered to low Earth orbit somehow, and then you just slide down it. But that's like a late stage infrastructure solution. Uh, I think tethers and space elevator type solutions don't really work on Earth or anywhere with an atmosphere because the drag is like extreme. But tethers and space elevators actually are kind of more feasible for zero atmosphere bodies.
No, but you could have an elevator kind of lander from the orbit, right? You slowly have some sort of stringed lander that you lower it down with some sort of strings until you can throw it away.
So
Well,
the
I think
way,
this
It's like a crane, like a crane in
like an
space.
elevator, basically, right?
so the way
Yeah.
space elevator type schemes work is the orbital station has to be basically geostationary, or in the case of lunar, the lunar equivalent of geostationary, so that it's always above the same spot on the planet's or body's surface. And then you string like something like a very high strength carbon fiber strip or something. And then what goes up and down it is almost like a crawling robot. Uh, so it's not quite like lowering with strings. You kind of need a very heavy anchor in the stationary orbit, enough that I think it'll be a couple of orders of magnitude heavier than anything you lower down. And whatever goes down will almost climb down like a monkey. Like you might have like, gear two type mechanism or something. You wouldn't lower it with strings approach, I think. It would be more, it would basically be controlled descent. It wouldn't be gravity descent, really. Yeah, but this is science fictional future. Like nobody has solved the material science problem for space elevators. Like you can't manufacture, carbon nanotube strips of like 10 kilometers long. Yeah, that table is good. That table is basically science fiction shopping list.
That reminds me about a company I met a long time ago, like maybe 10 years ago, basically working on spider webs, okay? And basically trying to make materials using processes similar to what a spider would do. But looking at the website, I don't know what they're doing. Apparently, they're doing fashion. I'm not sure. Anyway, it's just put the link here. Okay, it's called Spiber. Okay, spider fiber. Okay, but it's not what I thought. So I'm sorry, because for a cable, elevators and so on, for all such kind of ideas, we always get back to the question of weight, right? So not sure how that could. So I'm not sure the website is useful at all. Okay, but
Okay.
yeah. Um, it is. Does it sound like this topic is about robotics?
Once a robot gets up to the top, it can do all sorts of stuff. But when it lands, by the way, you don't have to have a permanent elevator. You can just have it on a string and you drop it.
Right.
But it definitely has to do with getting the rovers in.
I think it's a robot in the same sense of very specialized biological life stages, right? Like between a caterpillar and a butterfly,
Hmm.
have the pupa stage, right? It's a very specialized single function life stage that does only one thing and it's like discarded afterwards, but it's still a living phase, the pupa phase. So I think landers are that kind of very special purpose robots. So yeah, I don't mind extending the definition of robot to
Mhm.
specialist things like that.
But do we consider, typically now the landing rockets to be robots?
No.
Like typically what SpaceX is doing, or I guess
Yeah,
Origin and so on.
yes, why
Yeah.
not?
I mean, they
Rope?
become base stations, right? They sit there, they release the rover goes around. They tend to have the more high power communications and payload stuff. So, yeah, if they're functional after they land, they are kind of like stationary base station type robots. Like, actually, robots, I think we tend to associate them with mobility. They're more like the plant equivalent of robots or trees. Like,
Hmm.
animals versus trees, rovers versus landers is a little bit like that.
Yeah, except the tree usually gets there by some seed being carried or flying there.
Very big seed that's the same size as the tree. That's what it is.
Or you
Yeah.
could just like have some sort of 3D printer robot, and then it prints itself into existence.
With regolith,
Yeah.
a regolith printer. There are a couple companies making habitat, right? Space habitat based on regolith, right? There was a
Yeah, yeah.
competition won by a company that printed a building not out of regolith but a similar material.
Yeah.
I don't know. That's a very interesting discussion today. Thank you all for that. Just we have a few more minutes. So shall we talk about your work on YaRG? Because on my side, on the Frame V2 port, I plan to start this week. So, but sorry, I'm delayed. Okay,
Yeah,
um,
it's okay.
but I'm still doing it. Huh?
Yeah, so I got the first draft. Let me share the screen. So this is the first draft from JLC PCB. It's far better than what I could have like done in like 1 month or two.
Hmm.
Uh,
Uh,
I don't understand. You kind of gave them the logical circuit and then they do the layout physical design?
yes, yeah. So basically, I did this much,
Ah, okay. And this
and
type.
well, I did. Yeah, so I used RPi. So KiCad now has templates, and then they have RPi had template. So I started with that. So it already comes with the cutouts, like the dimensions and this USB, all these big basic dimensions and stuff. And then I just placed all the components on the schematic with the correct footprint. And then I also placed it on the board where I approximately mounted them. So basically, the initial draft was given by me, and then the routing and was done by them. But they improved. For example, this is better. So I had all these voltage translators here. So they improved the placement a bit more than what how I had placed, and they changed some orientation. And then once you confirm the uh, like
Hmm.
lay or the placing of the components, and then they start routing it.
Hmm.
They also ask you about like how much current each line carries. And there are some copper weight questions they ask. How much copper do we want? I think it costs more money if you have more copper or something. I don't know exactly, but I told them okay, just whatever you feel would be nice for them. So they just adjust.
Do they also ask you if you have to have your name signed on it in the shape of the copper wires?
You don't generally do that. You use silk screen for generally if you want some graphics or something. So this Yakro tumbler hat
Yeah,
you see, it's called
yeah.
silk screen. So you can have
Ah,
graphics and stuff.
yeah.
So I took our logo, uh, and then KiCad has this image converter. I converted that into a footprint and placed it here.
Great.
Yeah, but this is starting to look good, and this is basically a good template for the next iteration. So for the next iteration, we can remove this Arduino Nano footprint and then directly use the ESP32 system on module. It will reduce the space, and then we can remove all these breakout boards, and then we can have a lot more stuff. So basically, the motor driver, the accelerometer, sensors, all can go directly on the board instead of via the
Mhm.
breakout boards.
The ESP is slightly bigger than the Arduino, right?
No,
The
it's
breakout, the
so
breakout.
basically this Arduino has a small ESP32 on top of it.
All right. Okay.
It has a small ESP32 module around this much size from last 5 chips or even smaller. So we can use that if we want less space,
Mm-hmm.
or we can use directly the system on module Espressif provides. So it will be like somewhere around here, and then we can remove all these breakout boards. There is a lot of stuff we can put it directly on. And then this USB is basically for the other ESP cam. So last time we were powering it with the battery, so I put a USB A footprint here, and this is a transistor which turns on and off this USB. So we can turn off the camera via this switch,
Okay.
and this switch is basically for turning on and off the RPi. This one.
So that allows some piecewise power management if we want.
Yeah, so basically you could turn off this transistor and then the entire power to RPi is cut off,
Mm-hmm.
and this will turn off the camera.
Same. Okay. Yeah. So the boxes on the right, USB and RG45. What do they represent? Sorry, I missed that point.
Which one? This one?
On the far right, USB, RG45.
Off of the board.
Where is it? USB. Ah, okay. This is the footprint or the this is the how it will look when it's on top of the RPi. So this is
Ah,
the
oh
USB.
yeah,
This is the
Great.
USB from RPi.
Raspberry
So
Pi, yeah.
this will sit here, and below it will be the RPi, and these are the RPi components. So
Right.
this is the RJ45 Ethernet port on the RPi.
Yeah. The layout for the Pi 4 and the Pi 5 is the same for those ports.
I think the dimensions are the same. So there is actually a cutout here, and then some like hatches here. I remove them. So there is a you can like have the flex cables coming from here, and then you can attach the uh, either a screen or on RPi5 it's a PCI Express port here on the left side, and somewhere here in the middle there is a like a ribbon cable cutout
Oh yeah,
via which you can bring out the
screen.
camera flex
Camera.
cable. So
Mm.
you can like bring the flex cable through the board, but I remove that because we don't need it. But we can remove like add it later on. So each RPi also our hat also comes with a EEPROM, and then basically like you can program it with certain parameters. So whenever the RPi boots up, it can query the hat, what features it has, and then enable uh, the kernel drivers and other stuff you need. So
Okay.
so I remove that too. So because like we are controlling the RPi, not the other way around.
Interesting. So potentially it can work with both the Pi 4 and Pi 5, right? And even the Pi 3.
Yeah.
Mm.
Yeah, so until RPi 4, I'm sure. But like once it fits on the 40 pin connector is the same, so it doesn't
Mhm.
matter like which RPi it is.
Anyway, the tumbler is a Pi 4, right?
No, in Tumblr there is no RPi.
It's an Arduino, right?
Yeah.
So sorry. Then for clarification, because the hat is called the tumbler hat. Do I miss something here? It's this is a hat for Raspberry Pi, right?
Yeah. So yeah, I named it like that, but it can be
Ah,
named
okay.
anything we want. It's like a hat or tumbler that you can put on RPi. But that was too
Okay.
long of a sentence.
Hmm.
So I just called it tumbler.
Okay, good. I see where we're going. Yeah. Super cool, huh? Thank you for sharing. Uh,
Yeah. So I've added, well, on the current, so this is the humidity and the accelerometer.
Mm.
So we have like 3-4 sensor on top now.
mhm.
And then I've also brought out the UART and SPI and I2C pins on the 40 pin connector. So you can connect the LiDAR scanner also on top if you want. So these pins. And then if you want more sensors, we can connect it with the I2C or SPI.
Right.
We can even connect a SD card via this SPI connectors. And basically it's done so that you don't need the RPi. You can run it just with the ESP32. Yeah, that is what I have until now. Probably
Okay.
they will design the second iteration. So I had asked them to do some changes because the motor current wires were a little thin. So I asked them to make it a little thick. Then probably they'll give the design files.
Cool.
Yeah, we have 5 minutes past, I think. It's enough for
Yeah.
today.
So now the time is stable, meaning that the time we made today is the time for the next few weeks.
Yeah.
Okay.
Okay.
Okay then. See you next week. Bye.
Okay. See you next week. Cheers.
Bye.